So today let's talk about some oscillators. Here I have some amplifying oscillator, some Royer oscillator and some blocking oscillator. So let's start with the Royer oscillator. We have some transformer, some inductor, two transistor, some resistor and resonant capacitor. The frequency of this oscillator depends on the inductance of this inductor winding or the transformer winding and the capacitance. And the way it works is that when you power the circuit up, one of the transistor will conduct first. Say let's say this transistor conducts first. It will energize this part of the winding, which will have negative here, positive here. So it will generate some voltage in the feedback winding, negative here, positive here, which will turn off this transistor and turn on this transistor, which will which will energize this part of the transformer, and it will create positive here, negative here. So it will turn on this transistor and turn off this transistor. So let's see the circuitry on an oscilloscope. And of course here's the oscilloscope, and let's power up the circuit. It's oscillating and the frequency is 26.3 kilohertz and it's a pure sine wave. And of course, looking at the waveform of this inductor here, which seems to be like this, and of course the waveform of the feedback winding here, which seems to be a sine wave from the emitter to the base of the one of the transistor. And here as you can see, the half sine wave and the plateau here, which tells the transistor to turn on, emitter to the collector of one of the transistor, and it seems like this, the half sine wave. So let's look at the another type of the oscillator, and this is called the blocking oscillator. When you turn on the circuitry, the current will flow through this resistor and it will try to charge this capacitor, and when this capacitor reaches a threshold, the transistor closes or the transistor turns on and energizes this primary winding. This is primary and this is secondary winding, and it will induce some voltage on the feedback winding so that this capacitor will start to discharge. And of course here's the waveform of the oscillator, and it seems to be 1.39 megahertz or 1.39 megahertz, and I guess the frequency depends on this RC circuitry or maybe the transformer, the transistor from emitter to the base. And here how the waveform looks like. So I guess the frequency is more dependent on the resistor and the capacitor, and increasing the capacitor might help. So let's try to watch some another capacitor in it. Well, I tried to increase the resistance and I tried to increase the capacitance too, but it seems to have no effect here. The frequency should go down, but I guess it's a bit higher now, 1.68 or 69 megahertz. So I guess the frequency is more dependent on the transformer, not the RC circuitry. And of course here I am to clarify something. Don't take these dots very seriously. These dots might be correct or these dots might be wrong. So don't take these dots very seriously.